In this video I'm going to be doing some edit poly work and just generating some pieces for kit bashing. So when you're learning about edit poly and you're learning the basics of modeling, it's quite useful to do some kit bashing work, that is building the components of a kit bash, because this enables you to practice the techniques and not worry too much about what it is you're making, because you're making something that's fairly abstract. So I'm going to start with a box, because boxes are good. Let's just pop that on the origin. So F4 to get it in the wireframe, right click and convert it to an editable poly. And I'm going to name this Gubbins. One of the most useful selection elements is polygon mode, face mode, triangle mode if you want. It's the surface mode. You can go in and just select faces and move them around. So in face mode, these three tools, the insert, the bevel and the extrude, are quite useful. So insert allows you to literally insert a face inside and it will keep the pattern of quads. Extrude will allow you to generate extra geometry and it extrudes outwards from the surface. And then bevel is kind of a combination of them. So it's an extrude and then with a scaling. And the scaling is non-proportional because it's pushing in from the edges rather than just uniformly scaling the surface down. In edge mode, my favorite tool is pretty much ring and connect. And this allows you to add extra geometry. I'm going to chamfer this so that I have some extra pieces. And then I'm going to make a mistake by extruding this out. If I just go in and extrude, you can see that this actually comes out at an angle because it's taking the average of the faces in the direction that they're pointing, and we call this the normal. So each face has a surface, effectively an imaginary line that comes off of it, and it averages those lines together, and that gives us this direction. Now what I actually want is I want this to sit flat on the floor. But if I do this, you can actually see that something weird happens to the geometry. I get this horrible black line and I get this kind of strobing effect. And that strobing is called Z fighting. And we'll probably explain why it's called Z fighting later on, but that's what it's called. So what I want to do is I want to avoid this. This is bad geometry. It's actually technically inside out. And if you wanted a tool to highlight it, I'm going to come up here, go to X view, and I'm going to select overlapping faces. And you can see that it's identified 6 faces. It's colored them in green. And you can see that we now have a clear indication of where the problem is. I'm just going to turn the X view off for the moment. So how can we fix this? What I want to do is I want to rearrange the geometry on this side. For me, that's about the easiest way to illustrate what the problem is and to get people to see the pattern when we talk about things like mesh flow. So I'm just going to delete this geometry. And then I'm going to go into edge mode and I'm going to go to bridge. And what I'm going to do is rearrange where the quads lie. So I'm going to select this edge and go from here to here. And then this edge from here to here and this edge from here to here. So you can see that I have quads. They're just arranged differently. And this is one of these kind of weird mathematical things that you have to get your head around, is how topology works, how mesh flow works, and how you can change the arrangement of edges. If I go back and move this face roughly down, you can see that we don't have the same problem. We don't have any infinitely thin triangle running along here. I'm going to do the same on the other side and try and grab that edge which I'm not going to be able to do, am I? So I know there's a face in there. It's not selecting, but I also know there's an edge in there, so I'm going to delete that. You can't have one edge on its own, so it will have completely deleted the face. Okay, I'm going to go back into bridge mode. The other thing I want to be concerned about, again, I'm not normally worried about this as an artist because trying to be freeform and precision isn't necessarily two things that run together very, very well. This vertex isn't going to be exactly on Z0. You can see that this one is and this one is because I placed them there. If you are particularly concerned about getting your vertices in exactly the right place, here's a technique that I tend to use a bit. You can use the snap grid, but I find it very finicky sometimes. Whereas what I do is I will measure. So if I select this vert, I can see this is the error. This is how far off the 0 it is. So what I'm going to do is I'm going to push it up so we can clearly see how big the error is. So we're about 3.5, and I'm just going to copy that. I'm going to select all these vertices, and I'm just going to make sure that I haven't accidentally selected something around the back, because I did. Aha, I've broken those verts as well. I'm just going to push that back. That's what undo's for. I will check it later. Okay, let's try it again. So this vert is this distance, and I've copied that. So I effectively want to move all these verts down by that distance. So I'm going to switch from absolute mode to relative mode. I'm going to paste this in, and obviously it needs to be in negative. And then I'm going to switch it back to absolute mode so that we can actually check. So this vertex is 12, this vertex should be 0, this vertex is 34.4, as is this vertex. So if you are concerned about getting things exactly lined up, that's a pretty good way of doing it. Chamfer tool is good. If you double click on an edge, what it will do is it will try and select the loop, as it were, the line that all of these connect together, and you can see it stops at this point because this is effectively a T-point or a pole. It's where there is no continuation of that mesh flow. I'm going to control click so that I can do the other side as well, and I'm going to go in and do a chamfer. That's pretty good. Let's look at the difference between beveling and scaling. So I'm going to do an insert here. I'm going to, let's first do the bevel. So if I bevel this, you can see that we are effectively pushing in from all of these points. And that is different from doing an extrusion and a scale, where we'll get two different shapes. So you can see, particularly with this edge here, how this effectively hasn't come pushed in anywhere near as much as when there was a bevel. Let's make that a little bit more obvious by putting them side by side. Let's move this and shift drag. Let's do the bevel on this one. And let's do an extrude and then a scale. And hopefully you can see how particularly this internal edge has actually scaled in differently from this internal edge. And that's because this edge is very, very close to the scale point. So therefore these surfaces haven't changed much. Whereas when you're doing a bevel, you're basically pushing in from all the vertex points. One of the things to be careful of when you're scaling or when you're beveling is what happens to any of the geometry that's very close together. So as you can see here where I've done the chamfer, we've got some vertices and they're fairly close together, whereas around here we have just single vertices. So I'm going to do an insert, and we can see that what happens is that geometry starts to collapse and distort. This will also happen if I do a bevel. So if I come out this time and start to collapse, you can see that we get all of this distortion and weird Z fighting. So you need to be very careful if you've got geometry that's very close together, that when you collapse that geometry, it doesn't start to intersect or overlap. The next thing I really want to do is I want to show you how symmetry works again, and just to get it cemented into your idea about how useful a tool it is. So I could go in and try and build in two sides as a kind of outrig on this. I need to be careful what I do with the geometry again. Let's do an insert first and an extrude. I'm just going to press G to get rid of the grid. So again, if I move this down into Z0, what will happen is you can see that one of these faces just almost completely disappears. This face in here is going to go. That's going to be problematic. It's going to cause geometry problems. So I need to be able to fix that. And if you think about this, what is happening is that when this vertex here comes down to this line, it doesn't have anything to attach to. So that is what is causing the problem. Is effectively what happens is the vertex is just resting against a line. It's not actually connected to another vertex. So the solution to this is going to be, let's put some more vertices in there. And just to make this clear, I'm going to come in and I'm going to delete this face. I'm going to go to edge mode. I'm going to go and insert a vertex. I want one here and one here. I don't have to be very precise about this because I'm just going to move them off to the side so that you can get a better appreciation of what happens. So I'm going to go and select my face again. I'm going to put it on the origin, and I'm going to go back and I'm going to target weld these verts. And now we should have good geometry on this side. I'm going to add a little bit more complexity to this. So I think chamfer is going to be good. Let's put a big chamfer in here, and I'm going to double the chamfer and try and get it equally spaced so that it looks pretty rounded. That'll do me. And then again on this edge. Now, normally when you double click, you can get a continuous line. If I'm double clicking here, it doesn't get a continuous line because even though these are quads, this isn't a quad, this is an n-gon. So I'm going to go in and manually select this edge, and then I'm going to chamfer this side as well. Again, I'm eyeballing stuff because I'm an artist, not an architect. I'm going to go in and I'm going to clean these verts up. Come on. Okay, that's good. Now, do I want to do the same thing around the other side? Not likely. I know that my pivot's in the middle of the object, and I know my pivot's at the origin. I can put a symmetry modifier on this. Go up to modifiers, mesh editing, symmetry. I know I want the y-axis, and depending on which way around it is, you may need to flip it. When you add a symmetry modifier, it tries to be semi-intelligent about it. So if you have a particular edge you want to work to, you can select that edge before you put the symmetry modifier on. So let's just delete that. So with nothing selected, it will focus on where the pivot point was. Let's just damage this side. I don't want it damaged that much. What we'll do is let's put an edge in here. Could have done a slice. Slice would have been neater. So this open edge, this border, isn't where the pivot is. If I go in and I select just one of the edges, and I use the symmetry tool now with a selection, so modifiers, mesh editing, symmetry, again I need to make sure I'm on the y-axis. You can see it's put the symmetry plane on the actual edge, which is useful if you want to do a symmetry that's not on the pivot. You can, of course, select the actual mirror plane itself and move that around. And if you want to, you can even rotate the mirror plane. Just be careful that you don't mess up your geometry when you're doing it. Okay, I've built myself a gubbins to go into my kit bash. One of the other things that you need to consider is whether or not all of the geometry needs to be connected. It's perfectly valid to add additional geometry just as elements rather than as objects. Let's go in and make a bolt head. I'm going to start with, let's start with a sphere this time. I'm going to convert this to an edit poly. I'm not worrying about geometry. I'm not worried about whether I've got too much geometry. Let's cut it off around about here, and let's just check to make sure that was clean, which it wasn't. That's okay. So I've got a border here. What I'm going to do is I'm going to shift drag. So I'm going to hold the shift key down and I'm going to drag it to give me the bolt depth. If your other object gets in the way, you can use this button down here called isolate selection. Makes the other one disappear temporarily. Okay, then I'm actually going to shift scale to create a bit of a bolt head. I'm going to then go and shift move, and finally I'm going to cap this by pressing cap. Note that this is a big complicated n-gon, and if we have a quick peek at the triangles, they're fairly messy, not necessarily in a bad way. They look pretty unusual, but this is actually fairly optimal for a game engine as opposed to if they all just meet at a point in the middle. But that's tech. We don't want to worry too much about that tech. After all, this is just kit bashing. Okay, I'm going to go out of isolation mode. Now, in theory, this Z-axis should be perfect. So I should be able to select and place this wherever I want. So you can see that it pops onto the surface as I move this around. Doesn't like that one though, does it? It's okay here though. If it's floating off the surface, this will be because our pivot's not in the right place. We can fix it manually by right clicking on this, and you can make some rough adjustments. What I prefer to do is, of course, is fix the problem. So I'm going to unrotate this and I'm going to put it back on the origin. My transform has floated off to the side. So I want this face to be Z0, and if I aesthetically think that that's too high, I can drop it down. Let's select and move again. Whoops, wrong one. Once I've got it in position, of course, I can just shift drag to make some copies. If I don't want it to float, in other words, if I don't want these to be separate objects, I want to be able to move them all together. And then it makes sense to just attach them. So I'm going to go back to the main object. And I'm in edit poly mode. I need to find my attach. There it is. You will note that I will have hidden faces in here. Again, this is just a kit bashing exercise. I'm fine with that for the moment. So, and again, if I want to make sure that it's symmetrical, I will need to reapply my symmetry modifier.